In the last episode, we said short-term memory has a hard ceiling, the context window. Today, we hit that ceiling and watch what breaks. Picture a genuinely long conversation with an assistant. 40, 50, 100 messages deep. At some point, the entire transcript no longer fits inside the model's context window, and as we covered in episode 4, when the window overflows, the oldest messages simply fall out. The assistant forgets how the conversation began. The very thing you told it at the start. Your name, the goal, the constraint, gone, right in the middle of the chat. So the first and most immediate memory problem every long-running agent faces is this. How do you keep a conversation going past the size of the window? The classic answer is conversation summarization. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here is the whole idea in one sentence. Conversation summarization means periodically taking the older parts of a chat and compressing them into a short-running summary, then keeping only that summary plus the most recent messages in the context window, so the conversation stays small enough to fit while still preserving its thread. Think about how you would catch a friend up on a 2-hour meeting. You would not replay every sentence word for word. You would say, here is the gist of what we decided. That gist is the summary, and it is dramatically shorter than the full transcript while keeping what actually matters. So why summarize it all instead of the simplest possible fix, just deleting the oldest messages? That cruder approach has a name, truncation, and it is exactly what happens by accident when the window overflows. You just chop off the start. It is cheap and fast, but it is blunt because it throws away information with no judgment at all. If the most important fact, your budget, your deadline, the decision you made happened to be in those first messages, truncation deletes it forever and the agent never knows. Summarization is smarter. Instead of chopping the beginning off, it squeezes the beginning down, keeping the meaning while shedding the bulk. You lose detail, but you keep the point. Let me show you the pattern most real assistants actually use because it is more clever than a single summary. It is often called the buffer plus summary approach. You split the conversation into 2 parts. The first part is a buffer, a window of the last few messages kept in full, word for word, because recent context is usually what matters most for the next reply. The second part is a running summary, a single compressed paragraph standing in for everything older than that buffer. As the chat grows, messages age out of the buffer, and when they do, they get folded into the summary rather than deleted. So at any moment, the model sees a tidy package, a rich summary of the distant past, plus the exact recent turns, all comfortably inside the window. The conversation can now run for hours and never overflow. And here is the neat trick at the heart of it. The thing doing the summarizing is the language model itself. When the older messages pile up, the agent quietly makes a side call to the model, hands it the old transcript and asks, summarize this conversation so far, capturing the key facts and decisions. The model writes the recap, and that recap becomes the new memory. The same tool that holds the conversation is also the tool that compresses it. It is summarization, the very capability we have leaned on since the early episodes, turned inward on the agent's own history. Now, the honest trade-off, because there always is one. Summarization is lossy. Every time you compress, you throw some detail away, and you can never get it back from the summary alone. Squeeze too aggressively and the agent will forget a small but crucial fact, a specific number, an exact name that got smoothed out in the recap. Squeeze too gently and the summary itself grows large and you are back to overflowing the window. So summarization is a balancing act between how much you compress and how much detail you preserve, and there is no perfect setting, only a sensible one for your task. This is also exactly why summarization alone is not enough and why the next episode exists. If you need to recall an exact fact from weeks ago perfectly, you cannot rely on a lossy paragraph. You need a different kind of memory, and that is vector memory, where we go next. So how does this land depending on who you are? As an individual, this is the invisible machinery that lets a long assistant chat stay coherent instead of going senile halfway through. You never see the summary, you just feel that it kept up. As a startup, this is often the cheapest, highest leverage memory feature you can ship, because as we learned with tokenization in episode 2, a short summary costs far fewer tokens than a giant transcript on every turn. So summarization saves you real money while improving the experience. And as a large enterprise, the caution is that a summary is an interpretation, not a record. So for anything that needs an exact audible history, a support log, a compliance trail, you keep the full transcript stored separately and treat the summary purely as working memory. never as the source of truth. So let us bring it home. When a conversation grows longer than the context window, you do not have to lose the beginning. Instead of truncating, blindly chopping off old messages, you summarize, compressing the older turns into a short-running recap and keeping it alongside the most recent messages, usually with that buffer plus summary pattern. And you let the model itself write the summaries. It is the simplest way to make a chat survive past its token limit at the cost of some fine detail. But that lost detail is the catch, and it points straight at the next problem. What if the agent needs to recall a precise fact, not from earlier in this chat, but from a conversation you had last week or last month? For that, it needs memory that persists across sessions and retrieves by meaning. That is vector memory, and it is exactly where we go next. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.